let's solve this algebra equation. Uh, you have the multiplication of these four factors: x plus 2x plus 3 and x subtract 4, x subtract 5, and the multiplication equals to 44. You're asked to solve for x. So how we are going to solve this problem? One of the approaches is to actually expand the whole thing on the left hand side, and then you end up with a polynomial with x to the fourth power as a leading term, and then you're going to have x to the third power, x to the second power, and x to the first power, and then a constant, right? But that's going to be hard to solve because the highest power is like the fourth power. um, it's going to be quite difficult to solve. So let's try to think of a different way of solving this equation. Um, so if we pay attention to the organization of the four terms, you have x plus 2 over here and then x minus 4 over here, right? So if you multiply these two terms together, you are ending up with x squared, and then minus 4 plus 2, you're going to get a minus 2x, right? Uh, and then if you look at these two terms, right? So if you multiply these two terms together, then you get an x squared, and then minus 2, right? Minus 5 plus 3, then that's going to be minus 2x, right? So if I do this, x plus 2 times x minus 4, I multiply these two terms together, and then I multiply x plus 3 and then x minus 5 together, right? And then I end up with what? I end up with, for the first square brackets, I'm gonna get x squared minus 2x minus 8, right? For the second one, I'm gonna get x squared subtract 2x, right? And then minus 15, right? And then the whole thing equals to 44. So now I can identify these two terms as being the same, right? So what I can do is to actually represent um, these two terms. I can actually replace or substitute x squared subtract 2x as, say, u, right? I'm going to represent x squared subtract 2x as u. So I'm going to get what? I'm going to get u subtract 8 and a u subtract 15 equals to 44, right? And that makes it slightly easier because it's gonna be a second order equation for u, right? And then I can expand this term. I can expand the left hand side, and then I get u squared subtract 23u, right? And then plus 120, right? And then equals to 44, right? And then u squared subtract 23u, right? And then plus 76 equals to 0, right? And then now I can solve u as a second order polynomial, right? So you have equation u is going to equal to um, you have a formula for solving this kind of equation, but we can factorize it, right? Because 23 is like 19 plus 4, right? And then 19 plus 19 multiplied 4, you get a 76, right? So what you end up with is minus 4 u minus 4 times u minus 19, right? And then equals to 0. So you get u equals to 4 or u equals to 19, right? You get two solutions for u, right? So now u equals to what? U equals to x squared subtract 2x, right, equals to 4, or x squared subtract 2x is going to equal to 19, right? Now we can solve for x as two second order polynomials, right? So for this particular equation, so for x squared subtract 2x subtract 4 equals to 0, we can get what's going to be the solution, right? What's going to be the solution? It's going to be so x is going to equal to 2 that's like 20, right? So it's gonna be 1 plus minus for 1 square root of 5, right? So that's two solutions, right? We got two solutions over here. And then x squared subtract 2x minus 19 equals to 0, right? And then for this one we are gonna get what? We are gonna get um, so that's gonna equal to 1 plus minus um, root of 1 plus 19, 20, right? 22 square root of 5, right? So that's gonna be our solution. So x has like four solutions. The first two is 1 plus or minus square root of 5. The other one is 1 plus or minus 2 times square root of 5, right? So that's the solution.